Scavengr is an augmented reality app that links organizer-created content with QR codes placed in the real world to guide hunters through an interactive and educational or entertaining experience. We'll now introduce the team.
Hi, my name is Samuel Martinez. Before Deep Dive, I worked at Verizon Wireless for almost 9 years. Verizon supported me earning my A, Network Plus, and a master's in adult education, but after so long supporting end users, I was ready to make a change to writing software. Thank you for taking the time to watch our presentation.
Hi, I'm Trace Decker, and I am a graduate of C&M Ingenuity's Deep Dive Coding Boot Camps. I was in the Java and Android boot camp, and I'm on the Scavengr team along with Samuel, Abby, and Jawed. And we're really excited to show you what we've been working on for the last 3 months.
Hi, I'm Jawed Mohammadi from CNM Ingenuity Deep Dive Coding. Since I had some background in computer science, I have spent the last 3 to 4 months developing my skills as a Java developer with Deep Dive Coding, where I worked as a team member and individual on many projects. We will be presenting one of them today. I hope you like it. Thank you.
Hello, my name is Abby Reyes. Before Deep Dive, I was working as a nursing assistant at Presbyterian for the last 3 years. Although I loved what I did, I wanted to pursue my love for computers and software. During Deep Dive, my love for software was intensified and I knew I made the right choice. With the completion of the Java and Android boot camp, I will be looking for a job as a software developer and continuing my education for a degree in computer engineering. Thank you.
Our project is an augmented reality scavenger hunt application that uses QR code to display multimedia hints with or without any wireless services. QR codes are simple images that a phone camera can easily identify even from a distance, in low light, or at an angle. User in the organizer role can set up a new hunt easily with default QR templates. Hunter users will be able to start a hunt by using a public link or a private invitation. Scavengr will track hunt progress and publish completion times.
We've identified a handful of intended users. Most of our thoughts centered around giving children something active and technologically interesting to do. So teachers, for example, could create low-cost lessons that get students moving, which has been shown to improve knowledge retention. Youth group leaders could have fun activities, maybe incorporate races by tracking completion times. Zoos and museums can update their exhibits, add new information, more interesting multimedia presentations without having to spend taxpayer money on renovating their exhibits. Parents, of course, are always looking for ways to get their children more active, more outdoors, maybe engage in more social experiences. And an app like Scavengr would be able to bridge the gap between kids that want to be on their phones and parents that want their kids to be outside moving around.
All right, so here is our entity relationship diagram. A couple of things about this is actually our entity relationship diagram for our complete implementation. Not every little detail of our current implementation represents this, but that is our plan over the next couple of weeks, is to get our current implementation all the way up to speed with our ERD. So to start things off, here we have our user entity, and the reason it has a 1 to 0 to many, or a 1 to 0 or 1 relationship with hunt activity and organizer is because every user, no matter what they are, is going to be a hunter or a user. And every user is going to have hunt activity for every hunt that they do, other than when they first install the app. Of course, that's why it's a 0 to many, is because there won't be any hunt activity from the beginning. But once they make that first hunt, then they will have a hunt activity per every hunt that they join. And the reason that we have a 1 to 0 or 1 relationship with the organizer is because there's actually a switch in the UI that allows the user, when they first launch the app and they're going through the registration process, it allows them to say if they want to be an organizer or not. And what that allows a user to do is, if they have switched that little switch to say that they are an organizer, then it allows them to create hunts and everything that is included with that. So they can edit the hunts that they've created, see the participants and the clues list that are included in that hunt and make any changes necessary that they may want to with their hunt that they created. And the reason we're using UUID for everything is just because it makes it a lot easier to not have any crisscross of getting the wrong things or getting the wrong hunt or user or anything like that. So we make sure everything that we want to be unique will for sure be unique. And back up there in the user entity, the reason we have OAuth token is because we actually use Google OAuth 2 for the authentication of the user when they first sign in. So that's why we use that. And so in the hunt entity, of course, every hunt's going to have a name, and every hunt is going to have an organizer assigned to it as well. And again, the UUID for hunt ID is just to make sure that we don't have any hunts that can have the same IDs and cause some weird bugs that might happen when somebody's looking for a specific hunt. So down in the clue entity, clue is actually a child entity of hunt. And the reason that is because every hunt is going to contain clues. And for each clue, of course, it's going to have a clue name, the specific hunt ID that it's attached to. And then down here where it says media, that's either going to be a photo or a video or a link that will take the user to a media for that specific clue. And then right under that where it says media tag, that's actually going to be the little QR code that the user can scan to say, hey, I found this clue, I want to move on to the next one, and to up their score in their hunt activity. So in the hunt activity, of course, you have to have a reference to a specific hunt, and you have to have a reference to a user. And then, of course, with the date started and date completed, I believe that we don't have the code that actually takes those values, forms them, and puts them in the database, but that is a plan for our next couple of weeks. And then, of course, the total time is how long it took them to reach the end of the hunt. And then, of course, an integer value of number of clues completed. And eventually, with all of the hunt activity information, we do plan on implementing kind of a leaderboard and a popular hunts kind of thing. So every user can see who's at the top or who's doing the best or what their score is based on all of the other users who use the app. So I'm personally really excited for that because I love going out and I love hunting for stuff. It's fun. So that's basically it for our entity relationship diagram. Again, a couple of things on here aren't fully implemented in our current implementation, but again, that is our plan, is to have everything in our ERD implemented over the next couple of weeks.
Technology used to create Scavengr included the Android standard library, which was used for the interface and back-end architecture of the application. Apache Derby built the database. Google OAuth was used for a user as authentication and to sign in. Google Vision was used for camera and QR handling. It was used when an organizer created a new clue or a hunter is working on a clue. JSON converted Java objects to their JSON representation. Hibernate was used by the server for data persistence, as it is an object relational mapping tool that we use to map Java classes to database tables. OKHTTP3 and Retrofit, which models the REST endpoints, handled client and server communications and was translated by JSON. ReactiveX was used for client data processing using observables and subscribe-on methods. Room and SQLite was used for the client database. Spring used to format access to the server.
When a user registers without selecting the organizer option, they are not able to create new hunts. They can still search for existing hunts, and this will return anything available on the server that is open and matches the search criteria. The next screen is a summary of the hunt. We have the hunt name, creator, the date if it's not a dummy hunt, and the number of clues available, as well as a description of the hunt. When you join a hunt, you're immediately taken to a camera view. You have a summary of the active clue, which you can hide if you so choose. When you scan a QR code, which goes a bit slow in the emulator, you'll get an alert dialog that will display the linked media for that clue. Clicking close here will advance you to the next clue. You can skip a clue if you choose, and that will be moved to the end of the list so you can come back to it. If you scan a clue, if you scan a QR code that isn't the active clue, you'll get a toast that informs you you've scanned an invalid code. And that's how a hunt works for a hunter.
The current state of our application is that an organizer is able to create and save hunts with default QR codes. The organizer is able to add media to these codes with each clue created. Hunters are able to search for a hunt based on the name of a hunt, by most popular hunt, and these are the hunts that are most active or most participated in, or simply looking at the list of active hunts on the server. We can also scan QR codes and display the linked media with a pop-up. This is displayed when a hunter is working on a clue.
So next is our objectives for the future. One thing we plan on doing very quickly is in-app QR generation. What that means is that once an organizer has created a new hunt and they've set the clues and they're ready to start assigning QR tags to the specific clues, this will actually make it a lot easier for creating new hunts, so they can just generate the QR tag, assign it to the specific clue, and move on from there. And we actually plan on implementing two different types of tags, the QR tag, but also the near field communication tag. So instead of just scanning the little QR tag, the user can also touch their device to the NFC tag or the object that could have that NFC tag, and then it will pop up on their device saying, hey, you found this clue. Congratulations. So one other thing we plan on doing is using a hunt details preview. And our goal for that is to make our app use the smallest amount of memory as possible. So what the user can do is preview hunts. Instead of having all of this hunt data stored on their device, all they do is store the details for the specific hunts that they're going to be using. So that way our app will actually take up the smallest amount of space that we can possibly can based on the user's specific needs or wants. And then lastly, our media uploaded to the server. With our current implementation, our media isn't saved on the database, but that is one of the things we plan on tackling very quickly over the next couple of weeks.
This concludes our presentation. On behalf of my team, we would like to thank you for taking the time out of your schedules to hear us present our application to you. We will now be open to questions.